What's up guys, it's Daniel Byer. Today I want to cover some concepts with solving the 4x4, and when I started building and developing my method, the first thing that I knew that I wanted to have was an efficient solution. And I knew that at first I thought that efficient solution was going to become a complex, thorough list of possible algorithms and solutions, and then I realized that there were actually simpler was better. And so the cool thing that I wanted to implement was block building to the 4x4, and Roo is a method that does that very well in the 3x3. So I want to take those best components of Roo, throw in some additional considerations, some extra sub-steps for the 4x4 at the opportune times to solve the cube as quickly and efficiently as possible. So the first thing is that I want to build my first two blocks. I normally start off with building the next to the first two centers and then committing to L block. So I've done 3 moves. I built this half bar, got it vertical, as well as this one. I want to do one more move so that way when I do my movement here, and I see that this pair was actually kicked out, so I'm going to kick that back in. I could have maybe done an R2, but I was already planning on this, and this happened to be ready. I'm going to do a triple U to attach that edge pair, and then I want to go ahead RU prime, and then a slice L2 to build that other pair. And now I'm free because I can either do my yellow orange or my red yellow. I believe that I'm actually going to go with a D prime U, wide R, and then pair that pair up, and then finish up this first block. I want to get this first block done, that way I can then transition to edge pairing. I was scanning, I saw the blue edge pair, and so these are all, I'll call them by their complement color. So if white's my second block, I'll just call it like a green. I see my green. I'm going to put the orange piece in, and I'm going to look for this edge pair, that orange edge pair as well, because I knew that that solution was fairly easy. So sometimes though it's not good to start off with a committing to building a 1x3 if you don't have sights on either your U or your D. So right now I have matching blocks, and sometimes it may be more advantageous to do non-matching blocks. That's one of the tricks that we'll use. This happens to be a matching block scenario, but so first thing I'm gonna do is I'm gonna get this blue solid. I see I have my L shape. I'm gonna connect the other half, this half bar, drag it back down, take this half bar, make this orange, and then I have the L shape, drag down the other orange that was in the U to finish up that half bar on the R slice. So I'm taking advantage of the fact that there are certain solutions that are just as easy and optimal to solve and having oppositely swapped centers. So this should really be green, but I'm going to have this stored as blue. So that way I can just quickly and intuitively, rather than doing the extra moves to move everything to here or worry about color scheme, I'll notice an easy pattern that will give me special algorithms to implement during a 4C extended. So now I'm into the LSC wings. So there's in Roo for A, B, and C, there's the last 6 edges you need to orient and permute, whereas during LSC wings we need to pair those same 6 wings. And the cool thing about this is that during this step, because you've already solved your first 2 blocks, you can recognize the state of parity before you finish edge pairing, and if you recognize it, you can actually solve it sooner. So the first thing that I see is I already have a solved pair. I see my DF, my 2 pieces are my white red and my green red, and I see that my other white red is at the back, and I see that this is a good pair, but I see that this is a bad pair. So I'm going to actually do my pairing. I'm going to do my U2 to line this pair up. I'm going to do M, U2, M prime. Immediately trigger into L prime, U2, L, solving this pair, U2, and then I'm going to solve this pair down to D, F with L prime, U2, L. So that was actually a really easy solution. So the next thing is, so now I've got 3, and I want to transition to my LSD Wings 4, 5, 6. So I know that I have an unsolved pair, and it should be actually a false bar, meaning that it's not solved, but I have 2 solid red stickers adjacent to one another. So now this is a common pair of the 2 bow ties. This is the mirror bow tie because the blue orange and the blue orange are both blue on top. So I look and I've got 2 good edges, a 3rd good edge, and a bad edge. So I have an odd distribution, but I have a mirror bow tie, so that means that there's not parity. So I want to get this. I know that I can take this mirror, and with one of them I can apply my arrowhead to bring this DB piece up, and this pair will line up so I can do my wide soon. I see my small triangle, so this, I see another bow tie, and they are one piece. This is another mirror bow tie case. So, but I know that there's not parity, so I'm ready to do my wide soon, so I can pair up with wide R prime, U prime, R, U prime, R prime, U2, wide R, finishing up edge pairing, and I have 1 and 1, 1 and 3. So once I have the CMLL, do my CMLL, and then I wind up with an arrowhead case. I do want to actually, before I do that, transition to here and do my Nicholas to finish up the edge pairing. So I've got a really easy case. So now, because I had oppositely swapped centers, I'm going to do my U2, M2, U2, and then I'm going to permute and swap these. So wide U2, M2, wide U2. Cool. Cube solved.